Good afternoon. Today we are discussing about the relational model. What is the main usage of the relational model? So before we are discussing about this relational model, what are the learn about into the database management system? Already we have to know the database management system is nothing but one type of software application that can be manipulating the data into a database. So already we have the representing the graphical representation of the entity relationship model, how we can know the entities and what are the types of attributes and what are the relationship between those are. And at the same time we have to know the what are the terms, that means what are the components are existing into the entity relationship model. So totally 3 components are existing, that means attributes, entity and relationship. So in that we have the discussing about these are all in the previous session. So what are the different types of attributes? Simple attributes, composite attributes, multi-valued attributes, single value attributes, null attributes. So these are derived attributes. So these are the different types of attributes. At the same time we have to learn about the ER model. What is the main usage of the ER model? It will be representing in the diagrammatic and graphical representation. So next, so in this class we have the discussing about the relational model. So what is the main usage of the relational model? So in that we have the discussing about these topics. So in that relational model we have the discussing what are the code rules and what is the main approaching. So in the relational model for a database, the management is an approach to managing the data using a structure and a language. So that is nothing but relational model. The main purpose of this model is to provide a declarative method for specifying data and queries. The users directly state to want the information about the database, what information they want to. And the management software, it can be used to describe the data structure, storing and the retrieving procedures and queries. Suppose this is the one of the relation is establishing between. So we have that is one of the table activity code and activity name, another relation date and activity code and root number, and next another relation activity code, date and root number. So in that we have the what are the main relation among these 3 relations. So in that activity code is the main part, because of in the first table we have to take the activity code, in the second table we have to take the activity code. So what are the similarities are there? The 24 is the main similarity, and we have extracting the date, activity code, date and a root number. So in that, so EF code, he can defining 12 important relational database rules that make the database as a relational database management system. Because of the every database every database we have the designing, so it must be following the rules and regulations. The EF code, he can introducing the 12 rules. So those rules are, we have the designing purpose, we have using first one of the relation is the one of the rule, that is the information. The information in a relation database must be presented logically in the form of rows and columns. So of the table, suppose we have the in the current days we can also following, because of the we have to represent any type of data in the form of tables. Tables is nothing but rows and columns. And guaranteed access, the second one is the rule, guaranteed access. Every data value in a table must be accessible through the combination of the table name and the column. Next, another rule, that is the handling nulls. A null values must be treated the system asymmetric was independent of the database. A null value is the different white space or blank. We have the representing. Suppose we want to insert the values. So in that, so we have using the insert the values. How we can save the values? Suppose I can create the table, student name, student number and his marks. Suppose I can entering the values, insert into table name values, the student number, student name, and he is the option the particular subject. That means I can give the space. That means how can I give the space? It is not possible. That's why I can giving the null, null, then it can be one row is created. And next, another one of the rule, using of metadata. The metadata must be stored and managed as ordinary data, and it must be accessible through the same tool that are used to access the actual data. So in that we have the using the another one of the rule, comprehensive sublanguage. The relational database system must support a common and well-defined language for data definition, retrieval, manipulation, and data integrity and transaction management. The sublanguage we have using the one of the structured query language. With the help of these language, we have the defining the data, we have the retrieving the data, we have the manipulating data, and data integrity and transaction management we have the taken about it. And next, view updating. The views must be designing as updatable views. How we can creating a view? So create view name as we have the writing the query select star from some employee number. Then immediately the view can be created. But what about the rule this contains? The view can be updatable view. We have that is the one of the rule. Next, another one of the rule, high level insert, update, and delete. That means we can manipulating. This rule states that insert, update, delete operations should be supported for any retrieval set rather than just for a single row in a single table. Suppose I want to the retrieving the data. How we can using select star from employee. Suppose I want the insert data in a particular, insert into table name, insert into table values. What are the values I am giving? How we can update the data in the single row updation and multiple row updation we can giving update set number. So that means update table name, set student number equal to 3, where the condition we have the writing. And that means one single row will be updated. Suppose I can giving the update and a query. So update student number, set student name equal to some Shiva. Then automatically the name will be updated. All the rows must be updated. So next one of the rule, physical data independence. Application programs or users are isolated from physical and storage structure of the database. That must be allowed to access any physical storage hardware is changed. So that means we have the storing the data into the form of the tables. The total information we will be storing into the database. The database it can be independently we have the accessing. So that's why we can using this rule. And another one of the rule, logical data independency. So application programs or users are isolated from the logical structure of the database. So the user he can access data in the structure of the table is changed. So what about the next one is the integrity independence. The relation integrity constraints must be definable in the relational language and storage of catalog, but not be application level. So integrity independence means we have the applying the some type of constraints. Next we go for the distribution independence. The end user and application programs are completely unaware of the actual database is isolated. So that means we have the second about these types and non-subversion. So if the system supports low level data access, there must be no chance to modify the structure of the tables. So that are these are the total 12 rules we have the defining. We have the designing the database. That means we are simply calling the code rules. And what about the relational data models? So the relational data model is the primary data model which is used widely around the world of data storage and processing. So in the concepts we have the storing purpose, we are using the what is meant by table. The relation is the formed of table. So this is the format storing the relation among entities. A table has rows and columns where rows represent the records and columns represents an attributes. Tuple, the single row of table. We can call it the tuple. Relational instance. A infinite set of relational database systems represents the relation instance. Relational schema. So in the relational schema describes the relation name. That means table name, attributes and their names. What about the relational key? Each row has one or more attributes known as relational key. which can identify in a row in the relation. And what about the attribute domain? Every attribute has some predefined value scope known as the attribute domain. And what are the keys? Keys are used to, so why we are using the keys? Keys are used to identify individual records of a table uniquely. So they are also used to represent the relationship between tables and maintaining integrity of data. A key is an attribute or combination of attributes that identifies the other attributes uniquely. Suppose employee is the one of the relation, so in that employee ID, employee name, employee designation, employee department, employee salary, the attributes can serve as a key. So in that employee ID can identify all the relation of an attributes in the individual employees uniquely. At the same time, we can also take the another example of the student. So student contains attributes that is student ID, name of the student, name of the course, and address. So in that relation, the student ID can identify all the relations student uniquely. And what about the simple key? The key which consists only one attribute is called the simple key. Composite key, the key which consists of multiple attributes is called the composite key. And what about the super key? Super key is any set, any key that uniquely identifies the rows of a table. Example, suppose employee relation, employee ID, employee name, employee department, employee salary, these are the relation in a table. So in that employee ID, we have the concept uniquely identify a key element. Employee ID, employee name is also super key. Employee ID, employee name, department name, employee department is also any super key set of a key is called a super key. Candidate key. A candidate key is a key or super key which consists the attributes that are sufficient for unique identification. Primary keys. What is the use of the primary key? A primary key is a key that's selected from a list of candidate keys. And at the same time, we can also call the primary key the combination of not null and unique key is one of the relation we can calling. So it is the choice of the database designer to choose an appropriate candidate key as a primary key. The primary key is used to build relationship among several entities in the relationship model. Foreign key. Foreign key is a attribute or set of attributes whose value matches the primary key value in the related table in the same database. Data integrity. So data integrity rules enforce database designer to design a good database. That means we have the consisting the data, that means we have the taken about the data integrity. The major types of integrity constraints are domain constraints, entity integrity, and referential integrity constraints. What about the domain constraints? A domain definition usually consists of the following components: domain name, meaning, data type, size, allowable values, and a range of values. So in this example, we have taken about the one of the table. So that the customer table. So in that customer ID, customer name are the two attributes. Domain name, the customer IDs and customer names. Description, the set of possible customer IDs. We have the set of possible customer names. What about the domain? We have mentioning the domain that we have taken about the character size 5 and the character size is 20. Entity integrity. Entity integrity rule is designed to assure that every relation has a primary key and that the data values for the primary key are all valid. It guarantees that every primary key attribute is not null. Referential integrity. So in the relational data model, association between the tables and the defined in the foreign keys. Suppose we have the considering the customer table. The customer table having the different attributes are there. The customer ID, name of the customer, address, city, state, and zip code. So these are the different types of attributes in the customer table. And also we have the considering the another one of the relation, that is the order. So in the order relation, what are the attributes are there? Order ID, order date, customer ID. So we have to take the another example, order line. So in that order ID, product ID, quantity. And next we go for the product. Product is also one of the relation, product ID, product description, product finish, product to quantity to hand. So these are the different relations we have taken about the concept. So in that relation, what is the relation is established? So in this example, the customer having the customer ID, customer name, address, city, state and zip code. The customer ID is the uniquely accessing, that is the key attribute in the order ID. So in the order table, order ID, order date and customer ID. So how we can relation establish these two relations? The customer ID is the one of the relationship among them. So next I go for the another one of the table, order line. Order line, what are the attributes? Order ID, product ID and customer ID. And what about the product? Product table, product ID, product description, product finish, price, quantity on hand. So in the order line and product having the same similarities of the one of the that is the product ID is the one of the key attribute. So in the with the help of these references we can achieving them. Relational algebra operations. The relational algebra is a procedure query language. So it consists of a set of operations that take one or more relations as input and produces a new relation as output. So fundamental operations are select, project, rename, set difference, cross product, union. Selection. So what is the selection? The selection is used to select the required tuples of data from a relation. Suppose we have to take the one of the example, details of member who were born on 21st October 1997. So in that we have the writing and query. So how we write the query? Select member ID, name, date of birth from members table where date of birth, where birth equal to 21st October 1997. This is the SQL query we are writing and we are getting the access. So in that relational operations we have to take the selection. That means select the data. How we can select we have the selecting means we have the symbol sigma. So in the sigma date of birth, that means we have the particularly selecting, that means retrieving the data. So date of birth equal to 21st October 1997. We have to write the member as a relation. Then immediately it can be identified. So what the relation? In the relation, member is the relation. How we can accessing? It can be retrieving the data. Member ID, name, date of birth. These are the three attributes in the member relation. It can immediately identify who are born on 21st October 1997. Then immediately it will be picking the data. The member ID is 3, name of the member and date of birth, and the member ID is 5, name of the member and date of birth is only 2 members. We have the retrieving the data by using the select. That means select the tuples. Projecting. Next another one is the projection. The projection, it can be denoted, the symbol is pi. The projection is used to the required columns of your data from a relation. So we have the writing the query. That means we have the example, member IDs of the member who have borrowed books. That means borrow is the one of the relation. The member in that we have the taken about the who are borrowing the books. So that means we are the projecting the only one single column. That means we have denoted the symbol is pi. Pi member ID, that means column name, and borrow is the relation. Then we have the retrieving the data 1, 3, 4, 5. Next, rename. Rename operation allows renaming a certain output relation. Suppose we have to denote the symbol, that the rename library member and the relation name is member. Member ID, name, date of birth. Member ID is 1, name of the alias, and the date of birth is March 3rd 1995. And the next member we have the requiring, that is the Bob, July 1993. And next Charlie, member ID 3, October 21st 1997. Next member 4, Mike, September 16th 1992. Next 5 Katie, October 21st 1997. And next one of the relation, that is the cross product. So the one of the operation, the cross product is used to combine the data from two different relations into one combined relations. So that means A cross, suppose A is the one of A with n tuples and B with m tuples, that can be denoted the A cross B will consist of n dot m. That means the cross product we can also name the cross symbol or dot symbol, that means tuples. So we have to take the two relation of the tables. Member is the one of the relation and borrow is the another relation. So in that member relation having the member ID, name of the member, date of birth, and the borrow relation having the member ID, book ID, borrow date and return date. These two relations, the n tuples with following with the n tuples. The m tuples with following the m tuples. That means we are accessing these variables this way. Next another one is the set difference. The set difference operation in relation is very similar to fast set theory. The member ID, we have take the one of the example, member IDs of the members who have never borrowed books. Who have never borrowed books. So that means we have to take the relation 1. The relation 1 having the member relation. So what I have the projecting the member ID, name, date of birth from member relation. And we have like the another relation, member ID, name, date of birth. We have the combining the two relations because of we have the set difference. So we have to take the in that combining members and members will be joining with the borrow. Then we have to take the only one output will be there, member ID, name, date of birth of the only someone, the member 2, and the name of the member Bob, and date of birth is July 11th 1993. Union. The union operation in relational is very similar to that the set theory. Suppose we have take the one of the example, book IDs of the books borrowed by Charlie and Mike. So R1, we have the projecting the book ID and a name Charlie, member borrows to. Next another relation, we have the projecting book ID, name Mike, we have the joining R1 union R2. Then we will getting the book ID 2, 3, 5. Relational calculus. Next we go to the another one of the topic, relational calculus. The relational calculus exists in these two forms, that is the tuple relational calculus, domain relational calculus. So first one we are discussing tuple relational calculus. These filter the variables ranger over the tuples. So the notation we have taken about the T, we are writing the symbol tuple means T, and we are writing the condition. It returns the all the tuples T that satisfy the given condition. Example, we are writing them. Suppose tuple relation T dot name or writer T and T dot blog, that means information. Then we will get the tuple relation calculus. And next another one is the domain relational calculus. The filtering variables domain relational calculus makes use the relation attributes domain instead of the values of entire tuples instead of TRC, that means tuple relational calculus. The notations are we have the denote the B1, B2 and so on. Next we have the P means determine the formula of the inner attributes to build. B1, B2 are the attributes. Suppose we have the relation. What are the relation of the attributes? Page, article, subject that belongs to chocolate, and subject we have the mentioning the information, that is the domain relation calculus. Okay. Everyone, that's all. Thank you.